Hello all, welcome to the Introduction to Programming course. Before diving into Introduction to Programming course, we must know what is computer and what are the main parts of computer because we use input and output statements in our programming terminology. So you should know what is input and what is output, what is memory and what do you mean by process. So in order to understand these terms, you should be able to understand what is computer and how the communication happens in between different parts, how the memory is organized. So we'll see what is computer and what are the different parts of computer and how they are interlinked. We'll see in this video. So basically our agenda for this video is what is computer and a block diagram of a computer, or you can say organization of a computer. So let's get started. So a computer is an electronic device. So it is an electronic device and it can store. That means it can store, retrieve. Retrieve means you can pull out the data and then process the data according to set of instructions. So here the set of instructions means programs. So what do you mean by program? It is a set of instructions that are given to a computer to perform a task. It is essentially a machine that can follow complex directions to perform a wide range of tasks. So here is the breakdown of its characteristics and some key components. So we'll see what are the characteristics of a computer. So first one is high speed calculations. We already know that computers can perform calculations much faster than humans and much more accurately. So it won't go wrong. So most of the times you can say 100% the computer will give you correct answers. So the speed is unmatchable. The speed is so fast because of the advancement in microprocessors. The speed is in a jiffy you can get the answers. And the second one is data storage. They can store large amounts of data and retrieve it quickly. So we have hard disk drive and solid state drive. So you can store the data permanently. So there are two types of memory. We have RAM and ROM. RAM stands for random access memory, so which is a volatile memory. So we'll see. And ROM is read only memory, that is a permanent storage. So we can store the data permanently and we can retrieve the data effectively and fastly. And the third one is versatility. Computers can be programmed to perform wide variety of tasks. So by using computer we can deliver lectures, by using computer we can program something, by using computer we can see some movies. So it can perform wide range of tasks. So from simple calculations to complex simulations. So we can simulate the car driving in simulation softwares. We can design car models in MATLAB or something. So that is the meaning of versatility. And the second one is, and the fourth one is automation. So they can automate repetitive tasks and thus by saving time and effort. So by using computers, we can automate some tasks. So for that also we need from some programming. To give you extra information, we use Python code to automate something, to automate Excel sheets or to automate to download results from a web page. We use Python extensively. So as part of this programming course, we will teach you C programming from 0 to the advanced level. So these are the some main characteristics of a computer, and we will see what is going inside. That means what is the block diagram of a computer. You can say basic organization of computer. A computer system can be broken down into several essential parts. The first important part is central processing unit. So basically stands for CPU, often referred to as the brain of the computer. The CPU is responsible for carrying out instructions and perform calculations. It consists mainly three parts. So if you see this diagram, we have input. So let us understand overview and then we will dig deep. So first there is a box here, input. Input means input devices. We will give input to the CPU. So we as part of input devices, we have a keyboard and mouse, and then we have scanner and joystick. These are the input devices. So we can give input through input devices to the CPU. CPU thus processes the input and gives the output. As a nutshell, in a nutshell, a computer takes the input and processes it and then gives the output. Even the state of the art AI machines also does the same. So AI machines also take the input and process the data and relearn the process if there is a mistake with the human feedback, and then give the output. So basically, as part of computer science, we will take the input and process it and delivers the output. So we'll see what is output. Output is the desired result from the process, and we can deliver the output to the output screens. So basically console, that means your monitor or projector or printer. Okay. So CPU does the necessary calculations, and CPU has three main parts here. First one is control unit, and second one is arithmetic and logical unit, and third one is memory unit. So we'll see what three will does. The first one is control unit. It directs the operations to the processor. So control unit directs so it will direct which operations to be done by which unit, and it tells computers, memory and arithmetic logical unit and input devices how to respond to a program instructions. So if the input comes, a control unit decides which module will take the instruction, and then how to respond to that. So basically it controls the communication. And the second one is arithmetic and logical unit. This unit perform arithmetical operations and logical operations. So arithmetic operations means addition, subtraction, multiplication and division. We will see the topic called operators in C. In that lecture we will dive deep. And then logical operations. There are some and, or, not operations, and then comparison operations. So basically these wide range of operations can be performed by arithmetic and logical units. And third important point is memory unit. This is where your data and instructions are stored. So as we said already, so memory is of two types. So one is random access memory, and next one is read-only memory. So RAM is also known as volatile memory or primary memory, meaning that data is lost when the computer is turned off. If you turned off your computer, the memory in RAM will get lost. Okay, so RAM is used to store programs and data that are currently being used. So if you turn on computer, the booting of the OS will load. Basically, the OS will load into the main memory. Okay, main memory is the heart where your computer programs are run. Okay, so basically if you click an application, it will load that application into main memory. Okay, so main memory is the place where your programs will get executed. Okay, so the computers which are having more RAM will accommodate more programs simultaneously. That is called multitasking. So in terms of programming, we'll see what is multi-threading in Java or Python. So as of now, RAM is very fast when compared to ROM. RAM is very fast because your program needs to execute very fastly. Thus, by if it gets delayed, your user experience will get affected. RAM should be faster when compared to ROM, and if the RAM is more, you can accommodate more programs. That means you can run more programs simultaneously in the RAM. So nowadays RAM, if you consider my laptop, I'm using 8 GB RAM, But today there are 16 GB RAM and 32 GB RAM laptops are available. They are much faster when it comes to multitasking. And next topic is read-only memory. So if you want to save the data permanently, okay, if you want to save the permanently, if you're seeing this document, we have save button, right? Save button. So if you save this document, it will get stored into permanent storage. That means hard disk drive or solid state drive. So both are permanent storages. SSD is comparatively faster comparatively faster than hard disk drive. So nowadays most of the computers are having SSD. So we won't get much time to open any document or something. So ROM is a read-only memory. It is a non-volatile memory, and it is a permanent storage. If you store it, the data will be permanently stored, even if the computer lost the connection or computer turns off. The data will present there until you delete the data. The data will be definitely forever. And third one is input and output units. That means we have discussed these things, right? Now we will see what is input and what is output devices. So input devices, these devices allow users to interact with the computer. We can interact with the computer by using input devices, and we can see the output through the output devices. So what and all input devices we normally use? We use keyboard, mouse, scanner, microphone. I'm talking, right? I'm talking in the microphone. So these devices are used to enter data and instructions to the computer. And we have output devices, the monitor, printer, speakers, etc. These devices display or transmit information processed by the computer. So CPU processes the data, and output devices will receive that processed data, and it will get displayed onto the monitor. So we have another important topic called program counter. This is very important. So there is one course called Computer Architecture and Organization. You will learn more about program counter. So program counter, what it does is it keeps track of the instructions executed, and it will point out to the next instruction which is going to be executed. So basically, so normally we will read the book, right? So suppose the book has 500 pages. Now I have read 10 pages. So after 10 pages, I will pull out the thread. The book will have thread, right? So I will pull out the thread and I will save that location, 10th page location. So after some time, I want to resume the reading. So I will pull out the thread so that the current state, the where the left, that will be opened. So we'll continue from the 11th page itself. So that keep tracking of instructions done by program counter. So the much more information can be explained in the subject called computer organization and architecture. There you will know what is cache and what is cache hit and what is program counter and many other things. So these components work together to perform various tasks. The CPU fetches instructions from the memory using the program counter. So the program counter knows the instructions that are already done, that are going to be done as well, and decodes them and sends the signal to the ALU, performs some calculations and manipulations, and data and results stored in the memory, and users interacted with the system through input and output devices. This is the summary which we have learned so far, and that is the block diagram of a computer. So let us understand what is programming. So program is a set of instructions that are given to a computer to perform a task. So Normally computers can only understand zeros and ones. So we have different types of programming languages like low level language, uh, symbolic language or assembly language, or high level languages. So computers can only understand zeros and ones. So we have one type of language called low level language. So in which programmers back then in 1980s or something, I'm not exactly sure by the way. So at that time, very old time. So computer scientists only write it in machine level code. And for machine level code, the code will get executed faster. But the thing is, we are not comfortable writing in zeros and ones. We are able to remember a letters, not zeros and ones, right? So later, some symbolic languages came into picture. That is assembly language. Still, that is also very tough. And later, high-level languages comes into picture, where English level language instructions can be given to computer, and there is a concept called compiler. Compiler will take the high-level language as an input, and there is some. By the way, the compilation process is itself is a very big explanation. I mean, itself is a very. It has a lot of theory in it. So there is a subject called compiler design and formal languages and automata theory, in which you can study more details. As of now, your compiler takes the your high level language and turns into the machine code. But we'll see compilation process of the C language in a while. So that's it for today. I hope this session is useful. I will see you tomorrow. Thank you so much.